Today, we're diving into something that's absolutely critical in modern medicine. How do we bring artificial intelligence into our hospitals and clinics without messing with patient safety, equity, or trust? It's a huge question, and we're going to break it down.
So, picture this. It's 2 in the morning in the emergency department. Dr. Sarah Chen is with a 67-year-old man who's got chest pain. The hospital's brand new AI system flashes on the screen, low risk. But Sarah's gut, that clinical intuition, it's just screaming at her that something's not right. The guy is sweating, his jaw hurts. She decides to override the AI. She orders the full cardiac workup and, yep, you guessed it. He's got a 95% blockage in a major artery. Now, this story isn't really about bad AI. It's about why getting this stuff right is literally a matter of life and death.
And what Sarah's story really shines a light on is this huge risk we're seeing everywhere, what I call the cool tech trap. So many hospitals and organizations are jumping on the AI bandwagon just because it's new, it's innovative, it's the future. They're starting with the technology, not with the actual problem they need to solve for their patients.
And that difference is everything. Take Memorial Hospital. Their first shot at AI was a total failure because their whole reason for doing it was, we just want to be innovative. The result? A $2 million system that collected dust because nobody used it. But then they reframed the problem to something real, something tangible. Our emergency department wait times are over 4 hours, and it's putting patients at risk. Now that is when they started building something that could actually make a difference.
And this is the key takeaway here. The path to responsible AI isn't some piece of software you can just buy off the shelf. It's a framework. It's about building a culture of asking the tough, critical questions, not just once at the start, but over and over again through the entire life of the technology.
All right, so let's start with the very first question. This is the one that can mean the difference between a successful project and an incredibly expensive failure, all before a single line of code is even written.
I know, it seems almost too simple, right? But you would be absolutely stunned at how many multi-million-dollar projects can't answer this one simple question clearly. Are we solving a real clinical problem, or are we just chasing the next shiny object? The answer changes everything.
And to get to that really clear answer, you got to do the homework. Write down the problem in plain English. Go talk to the nurses, the doctors, the people who are actually going to be using this thing every day. And my personal favorite, apply the so what test. Let's say the AI works perfectly. So what? What specifically gets better for the patient? If you can't answer that, that's a huge, huge red flag. Okay, so once you have your why, the next step is to face one of the biggest dangers lurking inside of AI, hidden bias. You see, just because an algorithm is built on data doesn't mean it's objective. In fact, it can actually take our worst existing inequalities and just pour gasoline on them.
This is the question that should be keeping hospital leaders up at night, because an AI that works for, say, 80% of your patients can be dangerously wrong for the other 20%, and that's how you accidentally make health disparities even worse. So how do you find it?
Well, the key is you have to look beyond that big, shiny overall accuracy number. Using a tool like this, a bias detection matrix, you can break down the AI's performance across all your different patient groups. So you might see, okay, overall accuracy is 95%, which sounds great. But whoa, for group C over here, it drops to 87%, and look at their false positive rate. It's through the roof. This is how you find those hidden flaws before they hurt someone.
And believe me, this isn't just theory. There was a real-world dermatology AI trained mostly on images of light skin that was way less accurate at detecting skin cancer in patients with darker skin tones. That's not just a statistical error. That's a life-threatening failure that comes directly from biased data. It shows you just how important this is.
Okay, so you've nailed down your why, and you are actively hunting for bias. But what about when things just go wrong? Because, let's be honest, they will. That brings us to our next critical area, accountability. Think back to Dr. Chen's story at the beginning. The AI made a mistake. What if she hadn't been there to catch it? Who's responsible? Is it the doctor, the hospital, the software company? You have to have a crystal clear plan for this before an error happens, not in the middle of the chaos afterwards.
And this is the answer, an accountability map. It's such a simple but incredibly powerful tool. You just map out the different ways things could fail, a wrong diagnosis, a system crash, finding bias, and you define, right there in black and white, who is responsible, exactly what they need to do, and who they call for help. It gets rid of all the guesswork when every second counts.
So asking these questions, why are we doing this? Is it fair? Who's responsible? It's not a one-time checklist. It's really the foundation for building a whole culture of safety.
And that culture totally changes how you actually roll out the technology. You don't just flip a switch and pray. A really responsible implementation always happens in phases. You start off silent, then you move to an assisted mode, and only then, after all that, do you fully integrate it. This slow, deliberate process is how you make sure the AI actually works in your hospital with your patients, and it's how you build the trust of your clinicians.
Now, one of the most powerful safety checks you can possibly do is this first phase, the silent pilot. For months, the AI is running in the background. It's making predictions, but nobody sees them. Patient care isn't affected at all. You just compare what the AI would have said to what your expert clinicians actually did. It is the ultimate real-world stress test before you ever go live.
And it is so essential. One hospital was running a silent pilot for a stroke detection AI, and they found that it missed 12% of strokes in patients who had atypical symptoms. Can you just imagine if they had gone live on day one? The silent pilot caught a massive flaw and prevented a ton of potential harm.
So as we start to wrap this up, you can see it all comes back to asking the right questions, not just once, but all the time. The first one is the safety question. If this system went down right now, this very second, could someone be harmed?
The second question is about equity. Don't ever settle for good enough on average. You have to constantly be asking, does this work for everyone? Your oldest patients, your non-English speakers, the most vulnerable people in your community. Does it work for them?
And the third question is that accountability check. Is our plan still clear? If something goes wrong tonight, on a weekend shift with a junior doctor, does every single person know exactly what to do?
All of these questions, these frameworks, these checklists, they all lead up to one final and deeply personal test. This right here is the ultimate gut check. If the answer from you and your team is anything less than an immediate, confident yes, then you've still got more work to do. Because that is the real standard for responsible AI in healthcare. Now, if you want to learn more about how to build a framework just like this, you can contact Dr. El-Mustafa Boatern on LinkedIn, or check out his super practical guide, The Healthcare AI Revolution, which is available on Amazon.